Hello dear students, and today we will have our new lecture about power engineering. Last time, as you can remember, we talked with you about different forms and types of energy, and I hope that you didn't have any questions and any problems with your homework. Today, exactly, we are going to talk about power engineering, and first of all, let's determine what does it mean. Exactly, power engineering is a subdiscipline of electrical engineering and pertains to generating, transmitting, sub distribution, and utilizing electrical power while also catering to the devices, exactly electrical, which are used in above started processes, generators, motors, and transformers. A little bit about the history of this field. The very basic concepts of power system engineering were actually introduced in 1831 by Michael Faraday when he discovered the principle of electromagnetic inductions. The world's first power station was built in 1881 at uh, Goldmill in England. It consisted of seven Siemens arc lamp that was supplied with AC with 250 volts. It was further advanced to steam-powered electric power station in 1882. It was called the Pearl Street Station. The power industry kept on flourishing rapidly, and many power companies came into being in a very short period of time in Europe and United States. Further developments were made in 20th and the 21st century. The power systems were getting more efficient with passing time and have become a core area of electrical engineering field. Let's talk about practical uses. In many areas of the world, the governments maintain an electric network that can connect a number of electric generators by means of power. This combination of generators is called a power grid. Users can buy the electricity directly from the grid. The basic component of power transmission is a transformer. Transformers can convert power from higher to lower voltages and vice versa. There are basically two types of transformers, namely step-up and step-down transformers. Electrical substations are always present in a power grid to convert power to high voltages before transmission and to lower voltages after transmission. Basically, power engineering is a network of interconnected parts which convert different types of energy to electrical energy. There are three basic subsystems of modern power, namely transmission subsystem, generation subsystem, distribution system, and these three systems produce the electricity transmitted to load centers and transmit the power to the customers. Power generation means that the power is being transformed into electrical energy. Transmission system provides a means transporting electrical energy. Exactly, there are two types of transmission systems, namely built transmission system and sub-transmission system. Power distribution system basically transports power from the transmission system to the user. As network systems are expensive, so the distribution systems are normally radial. Voltage regulators, capacitors, and relays are all components of the control equipment. Job profile of power engineers. Let's talk exactly right now about this. Power engineers basically maintain, operate, and manage industrial plants which use equipment such as refrigerator units and boilers. Skills in power engineering are currently high in demand in many types of businesses and industries. Also, power engineers are employed in a variety of industries, including electric power generation, metallurgical industries, gas processing industries, chemical manufacturing industries, and paper manufacturing industries. All these industries may use boilers in their plant process. Depending on the plant design, the equipment may be indoors or outdoors, depending on type of industry. Workers may also be exposed to extreme temperature working conditions for some period of time, especially in summer. Employees in this occupation may be required at times to perform a certain amount of physical activity, including moving heavy objects such as chemical drums, vertical ladders, etc. Power engineers may also work on systems that do not connect to a grid. These systems are known as off-grid power stations and may be preferred to be used instead of on-grid system due to a number of reasons. For example, it may be less expensive for a mine to generate its own power in remote locations rather than pay for the connection to the grid, which is in no way practical. Nowadays, most grids have adopted three-phase electric power with alternating current. The power is split before it reaches residential customers whose appliances require single-phase electric power. But many large industries and factories use this phase electric power so that it can drive efficient electric motors such as three-phase induction motors. Guys, for today that's all about our new lecture. After this lecture, as soon as you can, please do some tasks in attached documents. And if you will have some questions, you can connect with me. See you soon. Goodbye, and I wish you good luck.